All right, welcome, guys. We're going to do a bit of Chapter 5 review. I know we did some of this in class, but Chapter 5, Section 1, we're comparing linear versus exponential equations in terms of money. So the idea here is that Janice received $2,500 bonus check from her employer. She wants to figure out whether she should put it in this savings account. Okay, so there's a bank. They give and say, hey, we'll give you for basic savings, you can have 6% simple interest, right? Versus the gold will give her less interest, less percent, but they say we'll compound the interest. So she wants to know which one to go with. You're going to help her out. All right, so for the basic one, well, you know, and a lot of you have forgotten from middle school how to get percentages. So in order to get 6%, you divide it by 100 and you would get 0.06. So that is the percent, the decimal version of that, 0.06. So in order to find out how much she has per year, you multiply 0.06 times $2,500. So every year she'll get $150. But it wants you to write a function. So your function would be, let me erase some of this. Your function would be f of time, okay? You can call it b of time for basic or whatever. And you would say, well, that's just the percentage in decimal times her amount, and then times time. That'll give you how much money she has. And then you want to add the original $2,500 that she got, that she started with. So here is your function right here. This one right here gives you your how much she gets extra every year, every 2 years, every 3 years, every 4 years. Basically, this is 150. So 150 times 1, times 2, times 3, times 4, depending on how many years. And then plus your original $2,500. Don't forget to add her real money. Now, the compound one, well, that would definitely need a function notation. So that one was the gold. Let's call it G. The G is determined by time, and that would be, that's the exponential equation, the geometric one that you could say. Well, it's whatever she started off with, okay, which is her starting money. But this one, instead of adding, we're going to multiply. And the formula is 1 plus the rate, and hers was actually 0.045. It was different, as you recall. They actually had less interest. And then that would be to the power of t. So to write your function, all you need to do is fill in your original amount. That's the only thing you know. And then the interest rate. And the variables would be time, and then, of course, what the total would be. This represents the total she'll have depending on time. That's what's called G of t. Her gold count versus, in terms of time. All right, so down here, now if you wrote this in your class during class and you didn't do it clearly or neatly, maybe just do it on a separate sheet of paper. Get some practice. All right, units. Units, we're going to measure those in terms of days, hours. Well, that would be years, okay? Years. And the expression we're going to use for that, we can call it T for time. We could call it Y for years, but that kind of gets a little confusing. All right, and then we want to use the units for our savings, so we're going to have that in dollars, not pesos or yens. And also in the gold, we're also going to keep it in the USA and have it as many dollars. The expression you would want to have here is this function right here, okay? So the expression would be, well, let's see. The expression was, it was 0.06 times 2,500. That gives you 6% of 2,500, which is actually 150. If you want to change that to 150, that would be better. So you don't have to rewrite it all the time. Okay. So you can use your calculator and just replace it. So say, oh, every year she's going to get $150. That's a 5. 150 per year, right? So times, whoops, I put year. I'm in time. We call it T. And then plus her original amount. Okay. So when it's 0, that's today. She has 2,500. And then in 5 years from now, she has 150 times 5 years. 5, because it says 5 here. And then plus the 2,500. And then over here on the gold, and then you do the same thing for these. Okay, just change this to 10, and then change that to 15. So, all right. But the compound interest, this is the real deal right here. This is where you have to use your compound formula, which is really nothing but an exponential. This might erase something. All right. So an exponential function. All right. So this one, the exponential function is, the expression is 2,500 times 1.045, because we added 1 plus 405, and then to the t power. Okay. So then for the rest of these, all you got to do is use your calculator and type it directly like that, 2,500 times 1.05, and then change the t. Whoops, hold on a second. I think I went a little too fast. This guy, if I can move this. No. This guy gets deleted. Because we started with $2,500, T is 0. And this is the one we started, 2,500 times 1.045 to the 5th power. Because we're multiplying the same thing 5 times in a row. And so on and so forth. So use your calculators. For this one, just change that to 10 and on and on. You want to be really good at using your calculator so you're not stepping on your toes as you're trying to do your exam. So you want to put the actual real number there, not my formula, but that's how you would type it in your calculator. And you want to compare how the numbers are less or different than each other, which one's greater, which one's less than, and that kind of thing. All right, so when you actually do your graph, you want to say, all right, I'm going to use red for mine for the simple interest. It started at 2,500. Okay, so that's 2,000, 3,000. So I'm going to guess it's right around here. And when you get these kind of graphs, I mean, you want to be as close as you can, not too close. And 10 years from now, you're going to increase $1,500. So thank you. All right. 10 years from now, it's going to increase by 1,500 because every year is 150. So I'm assuming that 10 years from now is going to increase 1,500. So I need a dot right there. Right here. So here is how I can actually connect my lines now. I want to use a ruler and just go boom, something like that. Make it a little nicer than that. And then on your, that would be my basic, okay? I'm going to call that basic one. And then I'm going to use blue for my gold. My gold, they also start at 2,500, okay? And I don't really have the actual answers for here. But I know for a fact that it starts out low, and you want to be able to plot some points here. Perhaps you could do this point, and then 5 years from now, it should have probably been around here. And then it should do some kind of this shape idea, this idea. So the goal is that you're able to see that the linear is higher, it's more, you get more money for a little while, okay? But after this point, after it crosses this point, which is, I don't know, I just kind of made up this one, the exponential is definitely a better deal. So time is the relevance. All right, this next section, next turn, when will she have 10,000 in her account? Well, you want to use your graph to kind of give you a good idea of when that is. Or you could use your table and figure out when she has $10,000 in her gold account. You can also plug in different values for t in the function and to see when you get really close to 10,000 or get there exactly.